This was a quiz covering the first half of our Introduction to Derivatives unit. So we'll be practicing the product rule and the chain rule and finding equations of tangent lines. However, we have not learned the chain rule yet. So if you're wondering why we do a couple problems a long way, it's because the chain rule is after the quiz. For number one, I will rewrite this before I take the derivative. See this x in the denominator? I'm just going to bring that out of the denominator and write it as x to the negative 1 power. So now I can more easily do the power rule. I will multiply the negative 1 times the 1/7 and I get negative 1/7. I reduce this power by 1. So this becomes x to the negative 2 power. And if this were a free response question, I could just leave it like this, but it's multiple choice. So let's go ahead and drop this down to the denominator again, and I will have negative 1/7x squared. So that matches up with answer B. Number two is a problem on which I would normally do the chain rule, but we haven't learned the chain rule yet. So I'm going to rewrite this by thinking of this as 2x minus 1 times 2x minus 1. So if you FOIL that, you're going to get 4x squared minus 4x plus 1. So now I can take the derivative by taking the derivative of each term. Power rule, 2 times 4 is 8. So I get 8x, I reduce that by 1. The derivative of negative 4x is just negative 4. And the derivative of a constant is 0. So this is the derivative. And oh look, it's right next to the answer choice, which is D. Problem number 3 will require the quotient rule, which is fun because I get to say the quotient rule poem. Low D high, less high D low, draw the line and down below, the bottom squared will go. When I say this, D high means the derivative of the top part, and D low means the derivative of the bottom part. So let's go through it. Low D high. So low is 5 minus 2x. And then D high, so that's the derivative of 2x, which is just 2. So there's low D high. Less means subtraction. And then high D low. So high is 2x. And then D low, the derivative of the bottom. This will be negative 2. Draw the line, and down below, the bottom squared will go. So that's the meaning of the poem. So let's just simplify this as far as we can and see what we get. Distributing the 2, we're going to have 10 minus 4x. And here we have a negative times a negative, so this will be plus 4x. And we tend to just leave the denominator squared alone. Negative 4x plus 4x, those cancel each other out. So I'm seeing 10 over 5 minus 2x squared. So this is where I would normally leave it. So let's see if this matches with any of the choices. And it looks like we have a match on choice A. Number 4, we need to differentiate this function. So we're finding the derivative. This will be the product rule in action. And for the product rule, you sort of go through this twice. The first time through, you take the derivative of the first factor and you leave the second factor alone. So the derivative of x squared is 2x. And I'm going to leave the second factor alone. So 2 over x to the 6th power minus 6x. And then you add, and now it's time for the second pass through. For the second pass, you do the derivative of the second factor, and you leave the first factor alone. So I'm leaving the first factor alone, that's x squared, and now I'm taking the derivative of the second factor. So you know what, as I do this, I'm going to look at this as 2x to the negative 6th power minus 6x. So I can more easily do the power rule. So here I go taking the derivative of the second factor. Negative 6 times 2 is negative 12. X to the negative 7 power, have to reduce that by 1. The derivative of negative 6x is just negative 6. So that's it. This is the derivative. If this were a free response question, I would just leave my answer like this, to be honest. However, this is a multiple choice question, so I need to match up my result with one of these, which means we kind of have to simplify this a little bit. So let's see, y prime equals, let's multiply through by 2x, little distributive property here. So this is going to give me 4x over x to the 6th power minus 12x squared. Then I'm going to distribute this as well. So I think I'll get rid of the, it's going to be negative in the front, so I'm going to put negative 12x to the, I'm adding these exponents, so that'll be the negative 5 power. And then minus 6x squared. I'm seeing some like terms here and here. So let's definitely put those together. So we have y prime is equal to 4, well, let's reduce this as well. So this x in the numerator is going to cancel out one of these x's. So we're going to have 4 over x to the 5th power. I'm noticing that we have this x to the negative 5 power. Maybe I'll deal with that later. So anyway, putting the negative 12x squared, negative 6x squared, that's going to be negative 18x squared. So I've got minus 12 over x to the 5th power. But like I said, sort of noticing that these are like terms. So 4 minus 12 is negative 8. So when you put that together, you're going to have y prime is equal to negative 8 over x to the 5th power minus 18x squared. So this should match up pretty well with one of the answers below. And there it is. Choice A is the answer. All right, these next few are free response questions, so I don't have to simplify. Haha. I'm going to look at this as the product of 2x times cosine x. So I will do the product rule. So when I do the product rule, I do the derivative of the first factor, and I leave the second factor alone the first time through. So the derivative of 2x is 2. And I'm going to leave the second factor as cosine x. Then I do addition, and then I switch it. The second time through, I leave the first factor alone, and I take the derivative of the second factor. So this is me leaving the first factor alone. And we've memorized that the derivative of cosine is negative sine. But what I like to do is, when I get a negative sign like this, I like to put the negative in the front. So I'm going to make this a minus instead. Okay, so the derivative of cosine is negative sine. So that's it. I don't have to simplify any more than this. So this is the derivative. All right, problem number 6. I am going to rewrite this slightly so that I can do the power rule more easily. So I'm going to think of this as x to the 5th power plus x to the 1/5 power. 5th root of x is the same as the 1/5 power. So now I can just take the derivative of each term separately using the power rule. So for the first term, that'll be 5x to the 4th power. For the second term, the 1/5 goes in the front. And then I need to reduce this by 1. So in my mind, I'm thinking minus 5 over 5, because that's the same thing as subtracting 1. So that'll be negative 4/5. And because this is a free response question, I'm just going to leave my answer like that. For number 7, I will rewrite this a tiny bit. Before I take the derivative, this 2 in the denominator. So this would be the same thing as having a 1/2 in the front of all this. Sine x plus cosine x. And so when you take the derivative and you have a constant in the front, you'll get the same answer if you take that constant and leave it out in the front of everything. So I'm really going to rewrite it this way. So now I'm going to go ahead and take that derivative, but that 1/2 is just going to be sort of sitting there in the front outside of the parentheses, while I go ahead and take the derivative of sine and cosine one at a time. The derivative of sine is cosine. We've just memorized that. And then the derivative of cosine is negative sine. So actually, let me erase that plus sign and put minus sine x. So this is the answer. For number 8, we are all set up for the product rule. The first time through, I will take the derivative of the first factor and leave the second factor alone. We've memorized that the derivative of secant is secant tangent. So I'm just taking the derivative of this, and I get secant x tangent x. And this time through, I leave the tangent x part alone. So I'm just going to go ahead and put tangent x next to it. Then I do a plus, and the second time through, I switch this around. This time I'm going to leave the first factor alone. So I have secant x. And I take the derivative of the second factor. We've memorized that the derivative of tangent is secant squared. So we will have secant squared. Okay, so because this is a free response question, we are definitely welcome to leave our answer like this. But, we have tangent times tangent right here, and we have secant times secant squared. It seems silly not to simplify this a little bit, so I'm gonna. So this will be secant x times tangent squared x plus secant to the third power x. So either of these answers would be acceptable. For number 9, we need to find all x coordinates at which the graph of function f has a horizontal tangent line. Of course, a horizontal tangent line means that the slope will equal 0, which means that the derivative will equal 0. So let's find the derivative and set it equal to 0. So f prime of x will equal 3x squared. We're just doing the power rule. 2 times 9, so we have 18x plus 24. So here is the derivative. But the question is, where does this equal 0? So let's solve this. I'm noticing that all of these are divisible by 3. So let's divide both sides of the equation by 3. We will get x squared minus 6x plus 8 is equal to 0. This will be factorable. X squared will only factor as x times x. 8 can factor as 2 times 4. I'm seeing that middle of negative 6x, so let's make both of these negative. Also, negative 2 times negative 4 is positive 8, so that works. By the zero product property, we will find solutions by setting these equal to 0. So that will give us x equals 2 and x equals 4. And actually, that's all they wanted us to do, was to find the x coordinates at which the graph has a horizontal tangent line. So that's it. Number 10 is the same thing, but with a trig function thrown into the mix. So let's find where g prime is equal to 0. The derivative of negative 3x will just be negative 3. And then I see that negative 6 sitting there, so I'm just going to bring that down. And the derivative of sine is cosine. So that is the derivative. We need to find where this is equal to 0, because that's when you will have a horizontal tangent line. So let's add 3 to both sides. So we will get negative 6 cosine x is equal to 3. Now we're going to divide both sides by negative 6. So we get cosine x is equal to negative 3 over 6, which is like negative 1/2. Well, where is cosine equal to negative 1/2? Let's start with the reference angle. Ignore the negative sign. Cosine of what is 1/2? You better have memorized that that is pi over 3. So the cosine of pi over 3 is 1/2. So we know that's the reference angle, but there are 4 angles between 0 and 2 pi that have a reference angle of pi over 3. There's one in every quadrant. What are the 2 quadrants where cosine is negative, though? Because we want negative 1/2. Cosine is an x value on the unit circle. So x values are negative over here on the left. So we can forget about this and this. We just want these 2. Remember that the reference angle is pi over 3. But in the second quadrant, this is 2 pi over 3. And in the third quadrant, this is 4 pi over 3. So these are the 2 solutions to this equation. And that's what they were actually asking us to find, the x values where the slope is equal to 0. So x equals 2 pi over 3 and 4 pi over 3. For number 11, we need to find the equation of the line tangent to the graph of y equals tangent x at x equals 2 pi over 3. Whenever they ask me to find the equation of a line, I'm going to use point-slope form, which looks like this. So that means I need 2 things, a point and the slope. So I'm going to organize my work like this. First I'll find the slope, then I'll find the point, then I can write the equation. So in order to find the slope, I'm going to find the derivative, because the derivative is a formula that will give you the slope at any point. So what is the derivative of tangent? We've memorized that the derivative of tangent is secant squared. So this is a slope formula. This will give me the slope at any x value. So what is the slope at x equals 2 pi over 3? All right, that's the x value that they gave us. So that slope is going to be secant squared 2 pi over 3. I'm going to do some scratch work over here off to the side. I want to evaluate the secant of 2 pi over 3, but in my mind I'm thinking, okay, what is the cosine of 2 pi over 3? And for that, I'm thinking, first of all, what is the cosine of just pi over 3? Well, we've memorized that the cosine of pi over 3 is 1/2. So what about 2 pi over 3? 2 pi over 3 is over here in the second quadrant. Cosine is an x value, so cosine will be negative in the second quadrant. So the cosine of 2 pi over 3 is negative 1/2. But we know secant is the reciprocal of cosine. So the secant of 2 pi over 3 is negative 2. It's just the reciprocal of negative 1/2. But we need secant squared. So this is going to be negative 2 squared. So therefore the slope will be positive 4. So that was the first thing I needed to find. So I have the slope is 4. Now I need a point that is on this tangent line. Well, they gave me the x value already. I just need the y value that goes with it. So it's going to go like this. I'm looking for a point. I have the x value. So to find the y value, I'm just going to use the original function. So y will equal the tangent of x, but we know that the x value is 2 pi over 3. So it's going to be the tangent of 2 pi over 3. So we have memorized that the tangent of pi over 3 is radical 3. So what about 2 pi over 3? Well, like I just mentioned a second ago, in a neater drawing than this, 2 pi over 3 is in the second quadrant. Tangent is negative in the second quadrant. It goes like this. Tangent is positive in the first and third. Tangent is negative in the second and fourth. So because tangent is negative in the second quadrant, tangent of 2 pi over 3 is negative radical 3. So now I can write the point. I already had the x value of 2 pi over 3, and now I found the y value, which is negative radical 3. Now that I have a point and the slope, I can write the equation. Using my point slope form, so I'm doing y minus y1 minus negative radical 3 is plus radical 3. And then slope times x minus x1. So x minus 2 pi over 3. And that's it. This is the equation of the tangent line at x equals 2 pi over 3. And here's what that looks like on Desmos. Check it out. All right. Number 12 is one of these problems where we have to find a missing constant. The line y equals 24x minus 11 is tangent to the graph of y equals 16x squared plus k, where k is an unknown constant. Find the value of the constant k. So we're given a tangent line. The main thing that tells us is that the slope is 24, right? Because y equals mx plus b. This is the slope. So this whole problem is about a point of tangency where the slope is 24. when you talk about the slope of a curve at a point, you're talking about the derivative. So the derivative is going to equal 24. So let's find the derivative, set it equal to 24, and see what happens. So using the power rule, 2 times 16 is 32. So we get 32x. The derivative of a constant is 0, so we write nothing. So here is the derivative. Setting the derivative equal to 24 and solving. So if we divide both sides by 32, we get x is equal to 24 over 32. Both of these are divisible by 8, so I'm just reducing. So this is going to be 3 over 4. So let's file that away for later. We know that the point of tangency happens at an x value of 3/4. At the point of tangency, the tangent line and the function intersect. So that means that this equation and this equation should be equal at that moment. So let's set these equal to each other and see what happens. So we will have 16x squared plus k is equal to 24x minus 11. But we know that x is 3/4. So let's go ahead and take this value of x and substitute it in, because that will then allow us to find k. So far we have this equation. Squaring the 3/4, we have 16 times 9 over 16 plus k is equal to, let's go ahead and divide 24 by 4, so that's going to leave us with 6 times 3 minus 11. These 16s cancel each other out, so we have 9 plus k is equal to 18 minus 11, so that's 7. And then subtracting 9 from both sides, we get k is equal to -2. Let's check this answer on Desmos. So if we have done this correctly, we found this k value. So that means the function, the original function, is 16x squared minus 2. And it should have a tangent line of y equals 24x minus 11. So let's put both of these equations into Desmos and see if we have a function and a tangent line. So here it is on Desmos, and the line is tangent to the function. For number 13, we're just taking the derivative of a function. We could use the quotient rule, but I think it would be simpler to rewrite this using the following strategy. If I have a plus b over c, I can write this as two separate fractions by doing a over c plus b over c. So I have a monomial of 3x, so I'm going to write that separately under each term. So f of x can be written as 2x to the third power over 3x minus 4x over 3x. This can be further simplified. This x in the denominator will cancel out one of the x's, so I'm going to be left with 2/3 x squared minus, and then both of these x's cancel each other out, so I just have 4/3. So now I can find the derivative very easily. We will just take the derivative one term at a time using the power rule. So this 2 is going to multiply by the 2/3, and that will be 4/3. And reducing the power by 1, I have 4/3 x. The derivative of a constant is 0. So this is just it. F prime is 4/3 x. So this is a multiple choice question, so let's just look down and see what we see. And the correct answer is B. Number 14 is sort of a continuation of number 13. Using the derivative you chose above, find all positive x-coordinates at which the tangent line to the graph of f is parallel to the line y equals 8x plus 9. So if the tangent line is parallel to this line, they are telling us what the slope is going to be. Y equals mx plus b. So the slope is 8. All right, that's the point of giving us this line. But derivative is the slope. So we're saying that the derivative must equal 8. So f prime must equal 8. So that means 4/3 x must equal 8. Multiplying both sides by 3, we get 4x is equal to 24. Dividing both sides by 4, we get x equals 6. And that's it. And just for fun, here's what that looks like on Desmos.